Our next topic, now that we understand chemical equations and how to balance them, is to do stoichiometry. Okay, so we're going to do stoichiometric calculations. So we're going to go back to the mole that we have worked on before, and the way I showed you how we set up those conversions using the line, we are going to be using that again because we're going to be taking many steps to get from the beginning of the problem to an answer. So let's take a look. What is stoichiometry? Okay. It is looking at proportional relationships. So let's do a real world example. I like to bake. So here is a recipe for making cookies. If I follow this recipe exactly as it is written, I can make 5 dozen cookies. Okay? But I go in my kitchen and I look and I say, okay, I have everything I need for this except I only have 5 eggs. I want to make as many cookies as I can, but I only have 5 eggs. Okay, so with 5 eggs, how many cookies can I make if I follow this recipe? Okay, well, I have 5 eggs, and the recipe says that I need 2 eggs to make 5 dozen cookies. Okay, so that's my ratio. 2 eggs makes 5 dozen cookies. Okay, now notice I put eggs on the bottom because keeping up with my units, those are going to cancel off because I want to know how many cookies I can make. Okay, and then I simply do what it tells me to do. Okay, I do 5 times 5, anything on the top, you multiply together. So 5 times 5, and then you divide by the number on the bottom. 5 times 5 is 25. 25 divided by 2. I can make 12.5 dozen cookies using this recipe with just 5 eggs. 12.5 dozen cookies. That's awesome. That's a lot of cookies. So now I can take 12.5 dozen cookies to the bake sale. Okay, so that's a real world example of doing stoichiometry. We're looking at the relationship of ingredients to determine an outcome. Okay, so in stoichiometry, we're going to be doing that exact same idea, but with chemical compounds. Okay, so it's the mass relationships between substances in the chemical equation, and it's based on the mole ratio. Okay, now the great thing is we know what the mole is, and we know how to balance chemical equations. And we know that when we balanced an equation, we put coefficients in front to be able to balance. So it takes 2 magnesiums and 1 oxygen molecule to make 2 magnesium oxides. Okay, so my mole ratio is these coefficients. Okay, it takes 2 magnesiums to make 2 magnesium oxides. It only takes 1 molecule of oxygen to make 2 magnesium oxides. So it's just looking at that ratio. How many of this do you need to make how much of this? So your steps to stoichiometry. Step 1, write a balanced equation. Sometimes I'll just give you a balanced equation. Sometimes I'll give you an unbalanced equation and you need to balance it. Sometimes I'll give you the description of an equation and you will need to write out that equation. Okay, so sort of where you're starting with that step 1 depends on the way the problem is written. But you've got to get to a balanced equation to move forwards. Okay. Next, you're going to identify your known and your unknown variables from the question provided, and we'll do some examples so you can see. Next, we need to line up the conversion factors. So using that line, putting things, where do we need to put things on the top, where do we need to put things on the bottom so that we can cancel off our units, because that's going to make sure that we are dividing and multiplying correctly. Okay, and there's lots of different things that we may need to use. We may need to use the mole to mole ratio. We may need to use molar mass. Remember, that's moles to grams. We may need to use molarity, which we've studied before, which is the moles to liters. We may need to use molar volume. That's a new one for you guys. That's moles to liters of a gas. But the core step in all stoichiometry problems, the step you will have to have in every single problem, no matter the way it's worded, is the mole ratio, the mole to mole step. And then we will evaluate our answer to see if it looks like something appropriate or if we maybe missed a step. Okay. Here's an important conversion factor for you to know. So I would add this to my sheet that I have. 1 mole of a gas is equal to 22.4 liters at STP, which stands for standard temperature and pressure. So 0 degrees Celsius and 1 atmosphere is standard temperature and pressure. And 1 mole of any gas will take up 22.4 liters at standard temperature and pressure. Okay, so add that to your equation sheet so that you will have that available. Okay, so we've seen this before. So we can convert between moles and numbers of particles, moles and mass in grams, moles and liters of a solution, moles and liters of a gas. I've added this one. This one's new to us. You've seen the other 3 before. So let's remind ourselves. If we want to get between moles and mass in grams, we use our molar mass, grams per mole. And remember, we can find that from the periodic table. Okay, what about if we want to go from moles to numbers of particles? We are going to use a constant, Avogadro's number, 6.02 times 10 to the 23rd. That's that counting number, okay? To go from liters to moles or moles to liters, we're going to use molarity, which is moles per liter. And now we have our new one that we're going to add up there. If we're using a gas and we need to go from moles to liters or liters to moles of a gas, we'll use our molar volume, which is always, that's another constant, 22.4 liters per 1 mole. Okay, so add that in, that section to the graphic in your notes. So that way you can refer back to this graphic so you know which way to go and what numbers to use. So let's do some example problems. So how many moles of KClO3 must decompose in order to produce 9 moles of oxygen gas? All right, step 1, we have to get a balanced equation. So we know we're going to have KClO3 decomposing, breaking down into KCl and O. So this is an example of one where you have more than a binary decomposing. So I would give you at least an unbalanced equation that you would then have to balance, or I may just give you the entire equation. Okay, so we have it breaking down into KCl plus oxygen. Okay, so decomposing. So this is now balanced. I have the balanced equation up here for you. Okay, next step. We have to identify our knowns and our unknowns. Okay, our known, it says 9 moles of oxygen gas. That's what we want to make, 9 moles of oxygen gas. And it says how many moles of KClO3 must decompose. So KClO3 is our unknown. That's what we want to know. Okay, and then we are going to set up our stoichiometry line and work our way through it. Okay, so always start with your known. What do you know? You know that you are going to produce 9 moles of O2. That's what you want. So we're going to write 9 moles of O2. Okay, now since we have moles on top, moles of O2 on top, we need moles of O2 on the bottom. So we're ready for that key stoichiometry step of mole to mole ratio. And we are going to use our coefficients. Okay, so we know from this equation that 3 moles of O2 on the bottom will create 2 moles of KClO3. And we're going to put that one on top. Okay, 3 moles of O2 to 2 moles of KClO3 because of the ratio. Okay, but we want to know, well, how can we make 9 moles of O2? So let's see what can cancel off. we can cancel off moles of O2 and moles of O2. Those are gone. We're left with moles of KClO3. What do we want? How many moles of KClO3? So this is as far as we need to go in this particular problem. So multiply across the top, divide by the bottom. 9 times 2 is 18, divided by 3 is 6 moles. Okay? And that works out perfectly because I need 1 sig fig, because my one number up here in the problem is a 9 and it's 1 sig fig. Okay, 6 moles of KClO3 is my final answer. Okay, all right, what if we need a few more steps? We need more steps now. Let's try a harder problem. How many grams of KClO3 are required to produce 9 liters of O2 at STP? Step 1, balanced equation. Okay, so we're still using the same equation as from the last slide, so we'll go ahead and write out our balanced equation. Okay, next step, define our known and our unknown. So we want to produce 9 liters of O2, so that is our known, from how many grams of KClO3? So that's our unknown. Okay, so I'm going to identify those. Okay, then let's start our stoichiometry line, starting with our known. Okay, so we know that we have 9 liters of O2. Looking back at that graphic with those squares, how can I go from liters of a gas to moles? Okay, that new constant I gave you, 22.4. Okay, so 22.4 liters, I'm going to put the liters on the bottom, that way those cancel off. And then the 1 mole is going to go on top. Okay, all right, great, so that's good. So now I have 1 mole of O2. Now that I am left with the unit of 1 mole of O2, now I'm ready for my key stoichiometry step, the mole to mole, using my balanced equation. Okay, so I have 1 mole of O2 on the top, so I need mole of O2 on the bottom. My coefficient is 3, so I have 3 mole of O2 to my unknown, 2 moles of KClO3. Okay, those came from my coefficients. Okay, my moles of O2 cancel off. Okay, and now I have mole of KClO3. So now I'm at my unknown. I've switched to my unknown, which is good. I'm partway there, but I'm not done yet, because what is my unknown? It's grams. So I need to go from moles to grams. So how do I go from moles of KClO3 to grams? I need to use my molar mass. Where does my molar mass come from? The periodic table. Okay, so this number right here, 122.55, I got from the periodic table. I looked at potassium plus chlorine plus 3 oxygens. Okay, that came from a periodic table. Add them together. Okay, now my moles of KCl cancel off. I'm left with grams of KClO3. That is what I want. I'm done. Now multiply everything on the top. 9 times 2 times 122.55. Multiply everything on the bottom. 22.4 times 3. And then divide top by bottom. So my final answer is 32.8 grams KClO3. Okay, if you put this in your calculator and you didn't get that answer, get into contact with me so I can help you. Okay, if you don't know where some of these numbers came from, get into contact with me so I can help you. Why 32.8 and not a whole bunch of other numbers? Sig figs. Come back up here. 9.00 is 3 sig figs. So my final answer must also be 3 sig figs. Okay, if you need help, schedule a private meeting with me. Let me help you.